Hello guys, welcome back. This is Danny, and today we are going to see about IP addressing and subnetting. Okay. Uh, First of all, what is an IP address? Uh, each devices and each network sources will be provided with an IP address. Okay. For example, if you are connecting your device with some Wi-Fi network, then at that situation, that Wi-Fi network will provide your device with an IP address. With the help of IP address, the data transfer will be happening. Okay, so there are three classes of IP address. Okay, and actually there are five classes, and now at this time three main classes are mostly used. Okay, A, B, C, and in these three classes, the the first I mean the first three will be the host, the network, and the fourth will be the host. Okay, and now let's go into the chapter. There are two scenarios in which we are going to discuss about the IP address and subnetting. In the first scenario, and each scenario will contain some sort of questions, about 4 to 5 questions, through which we will be learning comfortably and clearly. And in this first scenario, we are having a topology here, and in this scenario we have 5 subnets. You can, as you can see, first, second, third, fourth, and fifth. Okay, so there are 5 subnets in this topology. So the first question is, based on topology, how many subnets are needed? As we see now, there are 5 subnets. So the answer is 5. And how many bits must be borrowed to support the number of subnets in the topology? Actually, sorry friends, sorry for this inconvenience. Actually, this is the best source I can get right now, so please forgive me for this inconvenience. Okay, now so the question is, how many bits to be borrowed? Okay, actually there's a so this is the first scenario. Actually, um, uh, that's a formula. Okay, 2 power n. Okay, 2 power n must be greater or equal to the bits. Okay, if we put 2 right here, so 2 power 2 will be 4. Okay, and it's not greater than 5. Okay, this 5 is nothing but this subnet. Okay, the subnet is the 5. So if we put 2 here, then the 2 power 2 will be 4, so it won't satisfy the given condition. So the 4 is not greater than or equal to 5. Okay, so let's try with 3. If we put 3, then the answer will exceeds this situation, so it will be 8. And so uh, so this satisfies the condition, and the n will be 3, so the answer is 3 bits. Okay, and how many subnet does this create? Actually, if we put 3 here, it will be 8, so it satisfies the condition, and the subnet created right here is 8 subnet. Okay, but the subnet will be which will be used will be 5. Okay, in this 8 it will be a 5 will be used. Okay, and how many usable hosts per subnet will be created? So it is nothing but in this. Okay, in this there is this is a 8-bit. Okay, it's a 8-bit box, and in this there are 8 numbers. So the first 4 will be host part, and the last 3 will be, first 5 will be host part, and the last 3 will be network part. Okay, in this we will be moving the last 3 as 3 bits. Okay, so if we calculate and if we divide by 5, we will get 32. Okay, but you can see friends, the first bit will be taken for reference, and the last bit will be for broadcast address. So in this 32, if we just subtract the first and the last bit, we'll get 30 bits. Okay, so the answer will be 30 hosts. Now to calculate the binary values of first 5 subnets. Okay, actually the first 5 subnets will be nothing but the first one will be 0, and the second one will be 32, and the third one will be 64, which is nothing but the each subnet will be exceeds with 32-bit extra. Okay, so first is 0, so 0 plus 32, it's 32, and the 32 plus 32, it's 64. So likewise at each step it will be increasing with 32. Okay, So these are the binary values for those bits 0, the 32, 64, like that, etc. And now calculate the binary decimal value. Okay friends, uh, as we discussed about the subnet mask in the previous video, for each network there will be subnet mask created. Here it is 255.255.255.224. Okay, so so for 255 all the 8 bits are 1. Okay, so this is the binary value for 255.255.255, and for 224 this is the binary value created. Okay, so by using all the above informations, we are creating a table here that is nothing but the network address, first host address, last host address, and the broadcast address. Okay, as I said before, in a series, okay, in a series of IP address, the first IP will be of network address. Okay, that is nothing but it's like a reference, and the last bit IP address is for broadcast address. Okay, so the first is the network address and the last is the broadcast address. As we need 5 subnets, there are 5 series of IP addresses. So the first will be network and the last will be broadcast. The second to the first will be the first host address. Okay, and the previous IP address before the broadcast address will be the last host address. So that's all for the first scenario. And in the second scenario, each and everything will remain the same except the subnets. Okay, in the previous scenario we have seen 5 subnets here, but in this topology we will be seeing 7 subnets: 1 2 3 4 5 6 7. So there are 7 subnets. So based on topology, how many subnets are needed? It is 7 subnets, and the bits borrowed is 3 because let's see here. So the 2 power n must exceed than 7. Okay, so if we put 3 here, it's 8. So this condition satisfies. So the n is 3, so it's 3 bit, and the subnet created is 2 power 3, it's 8, so 8 subnets. And as it is 8, the remaining thing remains the same. So it is basically it's 32 host, but the first and the last is neglected, so we get 30 host, and everything remains the same. And here it is, the subnet mask is 255.255.255.224, and if we convert this this subnet mask exactly in binary, so this is the value, and thus the table is created. The first IP will be the network. Actually here we have created 7 subnets, so there are 7 series of IP addresses. So the first IP address for each series or network address, and the last is broadcast address. The next to the first is host address, and the previous IP address which is before actually the IP addresses which are just before the broadcast address or the last host address. So that's it for IP addressing and subnetting. Thank you friends.